Okay, so I guess we should go ahead and get started. I'm Itai Seggev, a senior kernel developer here at Wolfram Research. This is Garrett Ducharme, who will be giving the second half of today's talk. And thank you for being here. And I will be talking about the all-new Wolfram script. So Wolfram script is a new command line program. We had something previously called Wolfram script. This is a completely rewritten program with greatly extended functionality. I'll first be talking about the interactive uses of Wolfram script, then get a little bit into the script part of Wolfram script, and then Garrett will take over and give us more advanced examples. So what are some of the things you can do with Wolfram script? You can do one-shot evaluations from the command line. You can do cloud evaluations, including accessing... What's that? A larger. You can do cloud evaluations. You can run package files from the command line. Some extra bells and whistles are you can automatically export results to any format supported by export. You can apply operations to each line of a file as opposed to the file as a whole. And so let me just go in here and start with some examples. So Wolfram script dash code and $version. So I'm asking Wolfram script to evaluate the expression $version. It tells me I'm using 1101 for the Mac. If I want to evaluate this in the cloud, I just add dash cloud to the command line. Since this is my first time accessing the cloud, it's going to ask me to authenticate. And then it will go and think deep thoughts and hopefully come back with an answer in not too much time. Well, the answer, there it goes. The answer is 1101 for Linux, not for Mac, because it went to the cloud, and the cloud is running Linux. For my second example, I will cheat a little bit because I don't want to have to type a very complicated URL. But all of the commands are there in the notebook if you want to peruse them later. So here I am accessing an API. So I just say API, and that's not very nice. That usually works, but I guess we have a slow internet here. So I just give the URL to my API function, and I say -args x equals hello. And let's give it one more try and see if it behaves better. Here, I was having reasonably good results with the Wi-Fi earlier, so let me see if that behaves better. Okay, apparently I wonder if this is the problem. All right, so while the network is thinking, let me go on to something else. So running commands, package files from the command line. So I say Wolfram script dash file and give it the name of a package file. And why are we not hearing anything? Should we be hearing things? Is it HDMI? I have, oh, that, I did plug in, this is here. Well, let's just do that.
Good afternoon. I am a Wolfram language 1100 script. I was first executed in Urbana, Illinois, on the 24th of August, 2016.
So there's a Wolfram script pretending to be Hal. Let's see, have we made an internet connection? We have made an internet connection. So let's see if this script decides to work now. It does not want to work. I apologize for that. It would have said X is hello, and y was not given. And then when I said I could have given, in addition to x, I could have given a y value, and it would have told us x is hello and y is world. But apparently the network doesn't want to talk to us right now. So those are, right, another thing I wanted to show you. So I have a file with some palindromes that I'm going to show. So you can see a bunch of palindromes. And something I can do with dollar script input string, and we're going to take our input from palindromes.txt. So what have I typed here? So I've said string reverse, and I've typed in this weird script input string. So this is a new variable in version 11, which represents standard input as a string. It's only available when you're calling the kernel via Wolfram script, because it does the buffering needed for this. And so this is going to take all of palindromes.txt and string reverse it, and you can see it's completely string reversed. The lines are in opposite order, and the numbers appear on in reversed order on each line. But suppose I didn't want to reverse the lines. Suppose I just wanted to reverse the numbers on each line. So now I can tell Wolfram script, do this dash line-wise. Now it's going to feed each line one at a time to the script. And so you see the lines come out in the original order, but the numbers are reversed on each line. OK, so you see I've just been typing Wolfram script from the command line, which is not necessarily your native mode of operation on a Mac. Wolfram script can, in fact, does exist outside of a Mathematica installation. It also exists inside the layout, and it sort of wants to be associated with that layout if it's inside of it. But the executable is self-contained. By default, it will search for the best kernel it can on the local machine. You can specify a specific kernel using the dash local, or yes, the dash local option, dash local path to kernel executable. And the exact setup is slightly platform dependent. So on Linux, typically no setup is required because the installer installs things into user local bin, and including Wolfram script. If you customize that, you probably have a custom path and know how to set things up yourself, so I won't go through the details of that. Now on Mac, it is not available on the command line unless you run the installer. So when you download a disk image from Wolfram, you get a little folder that looks like this, and it says drag Mathematica to the applications folder. That gets you Mathematica. To get Wolfram script, you need to double-click on this extras and run the installer. In 11.0.0, we forgot to update the artwork, so it didn't say and Wolfram script. But in 11.0.1, we fixed that. And so it's no longer a hidden feature of the installer. And on Windows, unfortunately, it was just one of the things we didn't have time to do for 11.0, so it'll come with 11.1. It's still in the layout, so you can access it from the layout and or add it to your path, whatever is your favorite way of working on the command line on Windows. So that's interactive use. Scripts. So the scripts in Wolfram script means that it can be used to create self-contained Wolfram language scripts. And right now, this is supported on all Unix-like environments, which means Linux, Mac, and also Cygwin, MinGW, and whatever other crazy Windows Unix emulation environment there is. And all options, including cloud evaluation, can be used. I will get back to what that means on my next slide. But for now, if you don't know what I mean by a self-contained script, I mean a file which looks like this. It has this magical shebang line on first, but the rest of it is just a normal Wolfram language code. And if I were to run this, Whoops. And it will tell me no expressions were given to square, but if I say 2, 5, and x plus y, then it will tell me the square of 2 is 4, the square of 5 is 25, and the square of x plus y is x plus y squared. And so this first line is special. It tells the OS kernel to use Wolfram script to understand the rest of the file, and then the rest of the file is just a normal package file with Wolfram language or Mathematica code. So script files must have the executable bit. As I already said, other than the first line normal package files, and comments, whatever else you want. Additional options go on the command line. So an example of that is this script here, city distance kilometer.m. So you see I said dash function dash signature city city. So that says interpret this as a function and use interpreter to convert the two arguments given on the command line into cities, and then it will compute the distance between them. So if I say city distance, and I say London, and I say New York, then it will, and hopefully this doesn't require internet access, so it'll...
There's two expressions there. I wanted to know, is there any way to have a sandbox here so that someone says width, for example, or if someone tries to wipe your file, like the cloud has a sandbox?
I mean, you can probably pass dash sandbox to the kernel, and you could use interpreter instead of to expression. I guess I decided I trusted myself to not do run of rm-rf/.
But still, when you quit, what happens? Is that a standalone kernel which is fresh?
Yes. Yes. So it launches a kernel, interprets the file, and then exits. And theoretically, you could do dash cloud as if you wanted your script to depend on internet connectivity. Yeah, I guess we don't have sort of automatic sandboxing. That might be something useful. Yes?
I was wondering, is this still limited by licensed processes? Like, can I have 14 scripts running simultaneously, or is it still kind of limited by simultaneous kernels?
That is an interesting question that I don't know the answer to. I would guess probably yes, but I don't know that for a fact.
It's limited by licenses, but if you're using the cloud, you could do multiple requests to the cloud at the same time.
And typically I mean, in many common cases, these scripts don't run that long, right? So, I mean, some of them might, but, right. Typically, sort of the use cases for shell scripts is, you want something to run at midnight and it takes, 5 minutes, but yes, Mark.
So what's the advantage here of using your Wolfram script rather than having shell script that just launches the Wolfram kernel? Can you explain design?
So there are, the advantage is you could make it set UID probably because it's a binary. It's not a shell script itself, which on Linux the kernel launcher is in fact a script. And you have all these additional. I mean, if you want to use things like $script command line, which Garrett will talk about, and $script input string, those variables are set by this wrapper, which you won't get from just the script. Yes?
No issues with running rootless on the newer Mac OSs?
No issues with that. Please wait. You can ask me after. You can ask me pretty much anytime, Carlo. And so I'm going to skip over the detailed instructions because I want to have Garrett some time to speak. And look, it worked. Ye of little faith. Right, but these have sort of detailed instructions of how to take these examples here and turn them into actual script files on your local machine and play with them. And so with that, I will hand things over to Garrett.
Can you guys hear me? All right. So I'm going to give you a couple examples real quick of things you can do using Wolfram script. So this first one here is a script that generates a bell sound given a bass frequency. So I'm going to run my script here with a bass frequency of 400. And hopefully we can we hear that? So we can do a similar thing with a different input. It'll just generate a different bell tone. So now, if I go back here, we can look at how the script works. So starting off, we have the shebang line with our Wolfram script as a script interpreter. After that, we have our script command line variable, which allows us to take arguments in from the command line. So we're grabbing the second argument, which is our bass frequency, and then converting it to an expression that we could use. Potentially, we could use interpreter or something to make it a little bit safer. But for now, two expression works. Then we're doing our calculations, at which point I'm going to kind of gloss over that. We place it, create a file for it, export it, and get our Windows program to launch and run it. So that way it'll start the default program for it and play our sound. So this could be just an example script of something you could do with Wolfram scripts to generate something using an argument and produce output that you might use. I'm going to go on to another example here.
And let me just make one comment on that. So $script command line is very much argv of the C world. And so the first argument is the name of the script as you launched it. So it would be / whatever, or if you gave a complete path, it would be the complete path and so on.
Yep. So now I'll go through a quick example of deploying an API to the cloud, which is, if you're unfamiliar with it, it's like a function with interpreted arguments. So you can use that in a couple different ways from Wolfram script. So the first one here, I'm going to avoid deploying this because I believe it's under your account. But this script here, or deployed API function, gets weather data, generates a nice list for us, and then should print it out. So going to grab the UUID here. Let's switch back over. And we should be able to use Wolfram script with API and our UUID, along with a city. So let's give it Champagne, and hopefully our internet's good enough that we can get back. Oh no, timed out. So it should just be Wolfram script. I believe that's correct. I'm used to running it out of the current directory, out of habit, so Wolfram script should be how it runs. And normally there we go. So it generates us a nice list of weather data of the city that we've provided, or of the city that we've listed. So if I go back to our script here, we can see that the city argument that I provided corresponds with this city input here that we've made in our API function for it to take in. Now there's another way you can call this script, and that's to put -API. Oops. Mangling our slide, but that's okay. So that's a similar line inside of the script. The only difference is we're going to use Wolfram script as a script interpreter. So I can go back. Oh, now it is in the current directory. And I'm going to give it an argument again. And that should do the same thing. So many troubles with the internet here. But ideally, this would produce the same output as before.
Well, it did that time.
All right. I'm going to continue on with our examples. I think we know about what we would expect from it. So this last example is kind of an example of how you'd use images as input and output with a script. So sometimes that could be difficult to do, but here you can pipe in and pipe out images. So going to switch over to our script. I'm going to show us our base image. So all I've done is opened that image up. So we could see this is just a castle, and I'd like you guys to note that it's got a slight blue tint. So now I'm going to use our script here and input our castle. And output the resulting image. So you can see it gave us a little bit of information there. So we should be able to start that. And you can see this has much less of a blue tint than the original image. Hopefully we can see that. So we've got slight color balance from our script. So I can go back now and show us how that worked. So in our script here, we've got a couple different things. The first is that we're using script input string as Itai showed earlier. From there, we're going to import that data as a PNG because we want to convert that to something that we can use. We can do some quick error checking just to make sure that it is in fact an image, and then we can do our color balance on it. So the way we're going to output this to the script is we're going to use -print to make sure that it prints our last argument. So it's a convenience option for how you want the script to work. So that's going to make sure our last argument gets printed, and we're going to use -format PNG to use the abilities of export to export our PNG, or export our argument in the format of a PNG. The last expression, thank you. So once that's output, you can redirect that to a file, and you can display and see that as the images we did earlier. I'd also like to note that we have error. So in order to avoid writing to standard output to corrupt our image, we're able to write to standard error and have exit codes inside of our script. So all of the standard things you would want to use from a script.
So the return value is going to standard out. How do we give a return result? In other words, the script should execute successfully and would probably return 0, right?
Yes, it returns 0.
So but just with the normal return, it writes standard out. And okay.
Yep. So if you call it from another program, it should return 0 to that program. And now I'll hand it back over to Itai.
Yeah, thank you. So I hope you've enjoyed this little foray into Wolfram script. So things we're actively working on right now is integration into the Windows installer, so you don't have to handle that yourself. A standalone installer, so just a Wolfram script installer. So if you want to only use it on a machine with just cloud evaluations, then that'll be available. Also, double clickable scripts. So WLS extension, which stands for Wolfram Language Script. And like the scripts we've seen, will be a normal package file other than the first line should be a shebang line. But the difference is when you double click on it, rather than it opening in Mathematica, it executes the script. And so that's a way to make your scripts accessible to people who won't necessarily want to use the command line. Some additional resources, our marketing page, New in 11, had some nice examples. Wolfram Script has a dedicated page in the Documentation Center, which is the first of a new style of pages for the programs, which have been a little bit under-documented in the past. So we'll be refreshing those and a related tutorial. And so thank you very much. And are there any questions from people not named Carlo? Thank you.